We're going to cover an advanced feature of calculated data, and that's the totalization function of it. Now, in another video, we covered how to use calculated data to do really quick calculations of maximum, minimum range. But on to totalization. So what totalization allows me to do is essentially take an integral of something. So what I have here is I have a tag, and I'll just move it over. So this is my flow rate. I have a flow rate in gallons per minute, and it's defined by this pi tag right here. And I'm interested, as I would be, in, well, given that this is my flow rate, how many gallons did I produce over a week, right? So here is all the data I have. I have a lot of data. This is just the raw values I've been recording for gallons per minute of my flow rate. And I'm interested in, if I were to graph these, I've got the graph right here. You can see if I were to graph these, we can see what the values were doing over that time. So this is the flow rate over some period of time, and you can see that it ranges between 300 and 50. But this is just gallons per minute right there. And what I'm interested in is whatever it is that I need to get out, I want to know what was the gallons, right? Now, what I need to do is I essentially need to take an integral of this data. Or, said another way, I need to find out the area underneath the curve here. That will allow me to get gallons over this period of time. So this is a week. This is if you look at the dates down here, so this is over a week, and I'm interested in, over the week, how many gallons did I make? And in order to do that, I need to take a totalization, or an integral, of this data. All right, so back up to the top. And that's what calculated data allows you to do. You can just quickly come in here, and I'm just going to say calculated data, data item. Well, it's my pi tag right here, and the start time is clicking on G3. That's the start time. The end time is clicking on G4. Time interval, you don't need to use that right now. I'm interested in the number of gallons I had over the whole week. We'll see that in just a moment. And then I click apply, and I get a value. Now, at first, let's see here. This is supposed to be gallons. Gallons this week. And if you notice, 1,000, that's pretty low actually, because it looks like I'm producing around 200 gallons per minute on average, and that would really quickly over a week go well over 1,000. So what's going on here? And we can check this actually. So if I take an average of my data, so it's around 144 is this value here. That's the average flow rate. If I wanted to just do a quick calculation of the number of gallons I would expect to make over the week, I could say, well, I want to know it's going to be the average times 60 minutes in an hour times 24 hours in a day times 7 days. That looks like about 1.5 million gallons, which is a lot different than what we calculated below, 1,000 versus 1.5 million. So what is going on here? Now, what it is that we have a rate that's in gallons per minute, and the thing is pi tags are unitless. So if we're going to do a calculation with time as a variable, like every integral is a calculation with time as a variable, we need to know what the time unit is. And pi tags don't hold that. So we need to assume something. And what the pi server does when calculating a totalization, it assumes that we have units in gallons per day, or whatever rate we have is in per day. And you can imagine if this is gallons per day, then, well, 1034 suddenly seems reasonable. That actually makes sense. But we're interested in gallons per minute. It comes down to this conversion factor here. This allows us to convert time units from days to hours to minutes. And it goes with, you just put in number of minutes in a day, which is, for me, because I've done this before, I know that there's 1,440 minutes in a day. 1,440, I click apply, and suddenly you see this calculation is now in line with this calculation down here. They're both around 1.5 million. So we can see that these two are now in line with each other. Okay, now you might ask, well, okay, it looks like I can just do this in Excel, but why would I want to do it with this calculated data function? Well, let me show you something that you can do that you can't quite do as easily with Excel. I'm just going to move this down. So I'm just going to move this down. Maybe I want to know how many gallons did I produce each day this week. So I'll bring it down here. This day. All I need to do now is just change my time interval. So before it was over this whole week. Now I just need to say 1 day, 1D, click apply, and now I have daily values for each calculation. And I can even tell DataLink to show me the start time. So it looks like for March 11th, I produced around 270,000 gallons. March 15th, 294,000 gallons. And then it looks like on March 12th and 13th, I had a lull. I was producing a lot less. So you can very quickly bring this out to see like daily production totals very easily. Or basically anything that has a rate, you can get the integral of it and get the unit over some amount of time. Also, the other big bonus about this, when you do the calculation this way with a calculated data query, you don't need all this stuff. You can just delete it from your sheet, and you don't need to carry it around with you. It can just be elsewhere. And then your sheet is a lot more lightweight. You only have about 8 cells of calculations there instead of having 1,700 cells filled with data that you have to email around and move around, and it has to refresh every time, and it gets slower. This way, it's much faster, much more powerful, and it's really easy to just slice into the days with the time-based functions of PI Datalink.